Hello all, welcome to the day 75 of the daily case study series for CBSE grade 12. The question goes like this. Two motorcycles A and B are running at the speed more than the allowed speed on the roads, represented by the lines R vector is equal to lambda times I plus 2j minus k, and R vector is equal to 3i plus 3j plus nu times 2i plus j plus k, respectively. Question 1. Find the shortest distance between the given lines. The first equation given is r vector is equal to lambda times I plus 2j minus k, and r vector is equal to 3i plus 3j plus nu times 2i plus j plus k. From the first equation, we get a1 vector as 0 and b1 vector is I plus 2j minus k. From the second equation, a2 vector is 3i plus 3j and b2 vector is 2i plus j plus k. The formula to find the shortest distance is d is equal to magnitude of a2 minus a1 dot b1 cross b2 divided by magnitude of the cross product of b1 and b2. a2 minus a1 is 3i plus 3j. b1 cross b2, let's take down the ijk components of b1 and b2. For b1 it is 1, 2 and minus 1, and for b2 it is 2, 1 and 1, which is I times 2 plus 1 minus j times 1 plus 2 plus k times 1 minus 4, which is 3i minus 3j minus 3k. Magnitude of b1 cross b2 is equal to square root of 3 square plus minus 3 square plus minus 3 square, which is 3 root 3. The dot product of the difference and the cross product is equal to 3i plus 3j dot 3i minus 3j minus 3k. Multiplying the respective components, 3 times 3 plus 3 times minus 3, and we don't have k. So 0 times minus 3, which gives us 9 minus 9, that is 0. Substituting these values in the formula, magnitude of the product a2 minus a1 dot b1 cross b2 is equal to 0 upon magnitude of b1 cross b2 is 3 root 3, which is equal to 0 units. The first equation is given by r vector is equal to lambda times I plus 2j minus k. Multiplying the entire equation by lambda, we get lambda I plus 2 lambda j minus lambda k, and the second equation is given by r vector is equal to 3i plus 3j plus nu times 2i plus j plus k. which is 3I plus 3j, plus multiplying the entire equation by the new 2 new I plus new times j plus new times k. Grouping the ijk components, we get 3 plus 2 new I plus 3 plus new times j plus new k. Comparing the equation 1 and equation 2, we have lambda is equal to 3 plus 2 new and 2 lambda is equal to 3 plus new and minus lambda is equal to new. Let's name these equations as 3, 4 and 5. Substituting equation 5 in equation 3, we get minus new is equal to 3 plus 2 new. So 3 new is equal to minus 3, new is equal to minus 1, which gives us lambda is equal to plus 1. So these are the two values. Substituting the value of lambda equal to 1 in equation 1, we get r vector is equal to 1 times I plus 2j minus k. That is, r vector is equal to I plus 2j minus k. Comparing with the standard form xi plus yj plus zk, we get x is equal to 1, y is equal to 2 and z is equal to minus 1. This is the point where both the motorcycles collide. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.